Positive cycle here, for getting a positive cycle here, just see, we know that the direction of current should be from A to E. Now for the current direction from A to E, the P2 must be triggered first and N2 must be triggered in this after P2, because if P2 is triggering conducting, then the current will flow from A to E. But if N1 is being but when N1 is being conducting, then current will flow from E to A, okay, in this direction. So first we will trigger the thyristor number P2. Again P2 will be forcefully commutated at this point, and at the same time P2 will be forcefully commutated at this point, and again N1 will be triggered. Okay, see here P2 and N1 is in forward blocking mode, so if you supply the gate pulse, they will be triggered. Okay, so gate pulse will be decided according to these points, triggering points where we are triggering the thyristor. So gate pulse will not be same for P1 here, P1 here and P1 here, because triggering voltage are different. Here forward voltage is different, here forward voltage is different, here forward voltage is different. So at different times we will have a different values of gate current. Okay, but yes, P1 will be triggered. We have to trigger P1 at these points. Okay, so again P2 is triggered and P2 will be forcefully commutated here, and at the same time we will turn on N1. Again N1 will be forcefully commutated here, and again P2 will be triggered here. Again P2 will be forcefully commutated here, and again N1 will be triggered here. Again N1 will be forcefully commutated here, and P2 will be triggered here. Again P2 will be forcefully commutated here, and N1 will be triggered here. So see here, so for getting 6 times of for boosting 6 times of input frequency, we need each SCR to be triggered 3 times. So P1 and P2 are triggered for the 3 times. Again, so in the same way N2 and N1 are triggered for the 3 times. Then only we will get the 6 times of frequency. So similarly, if we need 4 times of frequency boost, then what will we do? We will trigger the P1 here, forcefully commutate the P1 here, and again we will turn on the N2 here. We will turn on the N2 here and we will forcefully commutate N2 here. Again we will trigger the P1 here, and again we will turn off the P1 here by force commutate here P1, and again we will trigger the N2 here. So 2 times P1 is being triggered and 2 times P1 is being forcefully commutated, and that's why our frequency will be boosted by 4 times. So similar, in the same way we will trigger here also. Here P2 will be triggered, this P2 will be forcefully commutated here, and again we will trigger the N2 here, and again we will forcefully commutate the N2 here. We will forcefully commutate the N2 here, and again we will turn on the P2 here, and in the same way we will do. Okay, see, so here we have boosted our frequency by 4 times. If we need to boost up our frequency 8 times, then for 8 times P1 will be triggered for the 4 times, P2 will be triggered for the 4 times, N2 will be triggered for the 4 times, and N1 will be triggered for again for the 4 times. Okay, so this is basically how a step up cycloconverter work. Okay, hopefully this will be understandable to you all. So in the next class video we will discuss the step down cycloconverter, where we will be using a natural commutation where we will down the frequency, input frequency. Okay, same circuit diagram will be used there also. Okay, thank you.